Good afternoon, everybody. Welcome to our webinar about climate change and the environment. My name is Sarah Goodwin. I'm a policy analyst at the National Center for Healthy Housing. This webinar is being hosted by the National Safe and Healthy Housing Coalition. I wanted to give a special thanks to our steering committee members from the Tribal Healthy Homes Network and the Asthma and Allergy Foundation who helped coordinate our speakers today. A couple of logistical notes before we get started. If you have questions throughout the presentation, go ahead and type them into the chat box, and then we'll be getting through them at the end. And also, this webinar will be recorded, and the recording will be available later, and you'll receive that in a follow-up email in the coming days. So to begin with, I would like to hand it over to Gillian Middlestat from the Tribal Healthy Homes Network, who's going to give us a brief framing of what we'll be talking about today.
All right, good morning or good afternoon, everybody. Sarah, can y'all hear me okay?
Yes, we can.
Okay, great. So again, good morning or good afternoon and happy almost Thanksgiving. I have 1.5 minutes of introduction here. And really what I just wanted to say is, and actually let me just step back and say I'm the director of the Tribal Healthy Homes Network, but my lens right now, I'm speaking as a member of the National Safe and Healthy Housing Coalition. I'm actually co-chair with Amanda Reddy. And in that capacity, one of the things I'm looking at is how the healthy homes field is responding to climate change. So what I wanted to just say briefly is, as you can see on the title here, we have a fair amount of scientific and academic research that's being conducted on the nature of climate change impacts. So we have a pretty good understanding what is the what, the breadth and depth of impacts to the indoor environment. But the question is what about our practitioner voice, which is how do we respond at the scale we need? If you'll switch to the next slide, Sarah. So just briefly as an example, this is one of the scientific reports, Climate and Health Assessment, and it's a pretty good compendium. I've shown air quality impacts here, but essentially this is one of many reports where you can find an encyclopedic discussion of air quality impacts and to some extent indoor air impacts. Next slide. And these are just example under air quality. They talk about asthma and allergy, ozone, health effects, wildfire. And I don't want to show you the specific subtopics there. The point is just I want to draw you to how we as practitioners are responding to this. So if you can go to the next slide, Sarah. So essentially, the academic and scientific research, we need that what. But those of you on this webinar today, if you're a healthy homes or an indoor air quality professional, or you're in a field that it works in close collaboration with those, you are probably on the front lines of impacts to the indoor environment. And what that means is you have the data, like you're going to learn more of it today, but you do understand to some extent. You have the field experience, but then you also have that firsthand knowledge of the barriers and opportunities on building not just the healthy homes, but on the programs and the systems change needed. So you're already working to mitigate lead, radon, mold, pests, and smoke. So you've got the how. And I say this is really important because I think as practitioners, there's a lot of work being done on the what, and that we now need to say, okay, we're experts at knowing how do you get into 5,000 homes in a community? How do you build and transform systems? And I think so I'm essentially just wanting to say that I hope we can continue this conversation. Join the National Coalition for Safe and Healthy Housing if you haven't, and join us in this dialogue about what practitioners know and how we can help change best practices that way. And I'll stop there and transfer back to you, Sarah.
Great, thank you so much, Gillian. So I'm going to introduce our first speaker now. So Eileen Gagne is an indoor air quality expert with over 40 years experience working in the built environment. She's a Tribal Healthy Homes Network technical advisor and trainer, adjunct faculty at the University of Washington Department of Environmental and Occupational Health Sciences, and a facilitator and trainer for the Northwest Eco Building Guild's Healthy Homes Training for Building Professionals course. So Eileen, I'm going to turn the controls over to you, and you can go ahead and take it away.
All right. Well, so can you hear me and see my screen?
We can hear you, but I can't see your. Oh, yep. Now we can see your screen.
Okay, perfect. Well, welcome everybody, and my apologies for the frog that seems to be inhabiting my throat right now. Anyway, so in terms of the built environment, as you heard, I have been working in homes and buildings for over 40 years. So indoor air is quite near and dear to my heart. So as we go through this, the environment in which people live, learn, work, and play have a tremendous impact on their health. And we all know that, we spend over, almost 90% of our time indoors, and our indoor air can be up to 5 times as polluted as outdoor air. However, there are certain groups, children, elderly, underserved, pregnant women, communities of color, are less climate resilient, therefore more vulnerable. So what you see here, I just wanted to go back a little bit and help explain what has happened with greenhouse effect, because that's really the start of this all. So the natural greenhouse effect is what you see on the left side of the slide, where you've got your solar radiation, carbon dioxide, nitrogen dioxide, methane, all of it sort of in a happy medium. However, ever since the Industrial Revolution, we have had significantly more greenhouse gases. So more carbon dioxide, more methane, more nitrogen dioxide. So less heat is actually escaping into the space. So here is actually the 10 indicators of a warming world, which we have seen. So once again, we get air temperature that the surface is actually increasing, water vapor is increasing, temperature over the oceans, the sea surface level, all are increasing. Sea levels are rising, sea ice is diminishing, ocean heat is increasing, and then the temperature of the land is increasing, and glaciers and ice are melting at huge rates, far more than what they had anticipated. So on this particular slide, what you see here is 2 different worlds, one in the change in average surface temperature from 1986 to 2005, and then on the top from 2081 to 2100, and that's just downright scary. The average precipitation, as you can see, is actually dropping significantly as well by the middle row, and at the bottom, the average change in sea levels is really increasing. So we're already losing islands, and I do a lot of work in Alaska, and some of the villages have already had to move or are in the process of moving inland. So, aren't you going forward? Let's see. All right, let's see. Oops. Let's try that. Nope, that won't go. All right, we'll do it the old-fashioned way. So, oh dear, sorry. Oh, sharing. So let me go back to this. There we go. So what you see here is all the potential direct and indirect consequences of climate change. Everything from extreme temperature events on the left to increased incidence of hurricanes, to drought, to wildfires, to irrigation, to outdoor ozone, pollen levels, geographic ranges of pests. And all of these things are reflected in the middle in terms of the potential impacts on the indoor environment, which are change in loads on HVAC systems, damage to and degradation of building materials, flooding, airborne particulates, increased indoor ozone levels, alterations in indoor allergen levels, and then on the very right, you'll actually see the potential increases from it all. And that's the issues that we're really concerned about. So I'm gonna focus right now just on wildfires. There are so many issues related to climate change. This could be a 3-hour, 3-day, 3-month presentation on this. So because of the length of this presentation, I really wanted to push to focusing in on wildfires. So I don't know if most everybody there knows about the wildfires that we've been experiencing, the West in California, Alaska, and then also thermal stress. So with the drying also comes a huge amount of thermal stress, from crops to lowered water levels to drying. And then, because the soil is no longer able to hold this and because the temperature's running, flooding on on the outside communities is also a huge issue. So here's a quote: "The sharp decline in summer Arctic sea ice has continued. It's unprecedented and is consistent with human-induced climate change." So, and I was just in Alaska, and it is just getting worse and worse and worse. And in this particular slide, you see the impact of climate change on human health. So on the inside, we have rising temperatures, weather extremes, and rising sea levels. On the middle circle, you see where each of those can affect air pollution, vector-borne diseases, allergies, waterborne, environmental refugees, mental health, water and food, heat, and severe weather. And then on the outside are actually the exact human health issues. So you have asthma, malaria, cholera, forced migration, anxiety, despair, depression, malnutrition, harmful algae blooms, heat stress. So it's amazing how it's so comprehensive, the damage this can do and is doing. So this is really one of the most important slides for me because it talks about toxicology 101. You have these factors that have critical importance on human health and our quality of life. So you have our exposure. So what is the exposure? So you have your biological, psychosocial stressors, your sensitivity. So what degree are you sensitive? So I'm 64, I have asthma, and I also have NCS, multiple chemical sensitivities. So I have a greater amount of sensitivity to some of these issues than other people. And then what's our adaptive capacity? So how can we, as communities, as people, or adjust to these potential hazards and take advantage of the opportunities? All of those mixed together to talk about the vulnerability that we have to climate change. And then because of the vulnerability, what are the exact health impacts? Well, given the nature of each person and each home and city and town and culture, everyone's going to have a different vulnerability and a significant health impact. So why are we so concerned about housing? Well, as I mentioned before, we spend up to 90% of our time indoors, and our indoor air can be 5 times as polluted as our outdoor air. So, you know, when I was growing up, I was outside all the time. I was playing, I was climbing trees, I was building tree houses, beating up boys, all sorts of good stuff, right? But nowadays, we're spending a lot more time indoors, mainly, I think, due to the computer. And it's been a blessing, but it also comes with challenges. And it turns out the quality of our indoor environment is a key determination of the quality of our life and our health. So with climate change specifically, attention to building quality indoors is incredibly important because it becomes more and more of a refuge against heat, flooding, dryness, heat stress, all those other climatic events which are changing. And we are going to have to adapt to these multifactorial challenges. So in terms of the external environment, we are concerned about temperature, our biological contaminants. Now already, last week, there are discussions about ticks in Alaska, which is a rare phenomenon, okay? Combustion-formed gases, formaldehyde, ozone, particulate matter, and VOCs. All of these things are very much a concern on the indoor environment. So the changes in our climate are likely to alter existing patterns of pollution, such as winds, vertical mixing, and rainfall. And our higher temperatures will definitely lead to increased ozone pollution and fine particulate formation. And as we've seen over the last 10, 12, 15 years, wildfires. The frequency, duration, and spread has increased because the higher temperatures, the drier winters, decreased rain, and the sort of expansion of bugs and pests, and extended periods of drought. There's so many factors that come into this. So in terms of buildings themselves, so all buildings experience what is called the stack effect. So air is really lazy. It will come in wherever it wants to, but it always wants to equalize. So what you have here on the left is the stack effect. So if anybody's ever grown up in a house where your bedrooms are on the second floor and your mom Saturday morning starts to make coffee or cook bacon, and all of a sudden that smell wakes you up, that's the stack effect. So everything that's down low comes up high. And then you have all sorts of other pressures from the winds, and we'll get into that later. Then you have common air leaks in a home. It's what you see on the right side of the screen. So anywhere air can come into the house, it will come because it's lazy and it's actually quite powerful. And as it comes in, it also can bring a lot of toxins with it. And I'm sure some of you have already experienced when your next door neighbor is either burning wood or using dryer sheets. That smell actually comes into your home. This is what's going on. It's the stack effect as well as the common air leaks. Now, in terms of the home or building itself, not only do we have exterior pollutant sources such as smoke, dryer sheets, whatever, ozone, particulate matter, but in some cases, more significantly, indoor pollutant sources. So you have dry cleaning fluid or tetrachloroethylene. You have paradichlorobenzene, which are air fresheners. You have chlorine-treated water in hot showers. You have trichloroethylene, once again, nitrogen oxides, asbestos. You have carbon monoxide from faulty furnaces. You have tobacco smoke, or in some cases where it's legal, marijuana smoke or vape. Radon, which is the second leading cause of lung cancer. Styrene, benzoate pyrene, which is produced by anything that burns, which is a known carcinogen, and formaldehyde. This doesn't even include all the household chemicals that people bring in. So and as we've gotten more energy efficient, we have tightened up our houses. So in some ways that's good for energy, but in other ways, depending on what is off-gassing in your home, whether it be your dry cleaning, your carpet, your furniture, your whatever cleaning products you use, they can actually create a very toxic environment. So here's a lot of the issues that we talk about indoors. For chemical, we talk about gases. You've got your carbon monoxide, carbon dioxide, ozone, nitrous oxide, your VOCs, disinfectants, paints, pesticides, all this good stuff. And if you all have ever opened up a can of paint that you had down in your basement or your garage for about 5 years and it's all dried out, where do you think those fumes went? Well, they evaporated and they came into your home or into your garage, which may have actually leaked into your house. Then we bring all of our stuff in. We have pets, we have mice, we have cockroaches, we have rats, houseplants, free-floating or biofilm-based microbes, pollens and allergens. Then you've got radon, I already talked about, particulates. And one thing I'm just going to say right here, never ever, sorry, I'm having a senior moment, never ever shred anything indoors. The amount of particulates that the shredders put out is phenomenal. So if you can, shred outside, covered outside of the weather. Then you've got your outdoors, your weather, your climate, your HVAC systems, and all your lifestyle issues. So we're going to look at just one pollutant. That happens to be wildfire smoke. So last year, there were 10,000 lightning strikes in Alaska. There were some villages that actually were stuck on their island and couldn't get off. But as you see, the fires are getting bigger, they're lasting longer, they're actually doing much more damage. They're occurring, as I said, with greater frequency, intensity, duration, and, obviously wood is a very inexpensive form of heating. And you can see 12 to up to 75% may burn wood as a primary or secondary heating source. So this particular slide, I really wanted to talk about all of the toxic chemical agents that have been identified in wood smoke. But also, here you have a picture at the top looking at burning going on outside. but it looks pretty toxic. It looks pretty bad, but look how nice and cozy the bottom picture looks. Well, those toxins are no different when you roast and toast your marshmallows than what you're seeing above that. So part of this is also making people aware that wood smoke is not as friendly and as nice as you would think. And as you can see on the right, there's a lot of VOCs, there are unsaturated hydrocarbons, there's polycyclic aromatic hydrocarbons, aldehydes, free radicals, inorganic compounds, a lot of free particulate matter. And as far as I am concerned, wood smoke is my biggest asthma trigger. I can no longer go camping because everybody in the morning lights their fire and the wood just hangs there and I can't breathe. So that's it for camping for me. So with particulate matter, why the concern? Well, I'm sure most, if not all, have seen this picture that is put out by the EPA about the size of particulate matter and the concerns. So a human hair is about, 50 to 70 microns in diameter. PM10, which is your dust, your pollen, is only about 10 microns, but it's these 2.5 particles. These are the particles that we're really, really concerned about because they will bypass your natural defense systems, your nose hairs, your throat, your cilia, and they will go way down deep into the lungs and actually can pass directly into the bloodstream. And here, this is an epidemiological study, have associated exposure to particles less than 10 microns, so those are your 2.5s, with increased pulmonary and cardiovascular morbidity and mortality. So the heart and the lungs work in tandem. If your heart's not working right, your lungs don't work right. If your lungs don't work right, your heart doesn't work right. But this is some of the issues involved with particulate matter. So, and here, this transgenerational epigenetic inheritance, what this means is that the wood smoke particles were found to be more powerful than other kinds of air pollution in causing potentially cancerous changes to DNA. And the white area in that slide actually shows the cancer-causing changes that were altered and damaged the DNA in lung cells. So it is our cause to really be proactive, preparing for climate change. And we can reduce the impacts while also facilitating a more rapid and efficient response, and to really think about the adaptive capacity and resilience to climate change impacts. So this was a study. So I do a lot of hands-on grassroots education. So this was a study that came out on Puget Sound Clean Air Agency with a do-it-yourself filter or fan. And what they did was they had two filters, one outside and one inside. And they wanted to see, and what this demonstrates is that what's outside is basically inside. As you can see, the red indoor line shows about the same amount of particulate matter and the same degree as outdoors. So what we can do about wildfire and wood smoke in our homes. So how many people actually have HVAC or filtration systems in their home? Probably not as many as we would like. And then on top of that, when was the last time a filter was changed? And here you see this filter on the right is new, and the filter on the left was taken out of a furnace after about 6 months. And I don't recommend this kind of fiberglass filter, but it shows you the difference between the two types of filter, the same kind of filter, but a clean one and a dirty. Now, this is a very small study, came from my home. So I have a 1906 home. When I retrofitted with a MERV 11, the new filter was installed in 2018 because we knew the wildfires, the smoke was coming. I had the Dylos Air Quality Manager installed, and I took readings 3, 4, 5, 6 times a day. And I had the HVAC system running continuously with that MERV 11 filter. And I had 2 HEPA air cleaners in continuous operation in the first floor office where I spend my time, and in the second floor master bedroom. And what you'll see is after 2 months, what you see, the first one is the post wildfire event, so that a clean filter was installed 2 weeks before this one. The filter that was taken out in the middle was taken out 2 months after that one. And that's just to show you on the right, a new filter. Now, what I'm demonstrating here is that the middle filter, since the wildfire event was over, the big particles were collected by the filter on the left. The filter in the middle actually picked up those tiny particles, the ones that floated around and eventually, and were behaving like a gas, and eventually may have settled out or been picked up by the HVAC system. So you have to think about the long-term exposure of these. Then this is the filter fan that there's a lot of these out there. It's just it's a $20 box fan that has a $20 to $40 furnace filter installed on the front of it. I did a group presentation, and we at a local nonprofit where we handed about 35 of these out to various Latino and Vietnamese families. And what you see in that slide on the right is example of how well this fan works. So you'll see the inside-outside graphs, and all of a sudden when the fan turned on, the almost immediate drop in particles. So it is an incredibly efficient and effective way at dealing with particulate matter with low-income homes. And you just there's a huge caveat with this, however. Never leave this fan running when you are not present or while you're asleep. We do not know yet what the extra pressure put on the motor will do with having the filter on it. The EPA is now starting to study that, and hopefully the studies will be out soon. So once again, and I thank you. And now we're going to go on to the next presenter. And thank you.
Thank you so much, Eileen. So I'll turn it over to our next presenter. Dr. Jeffrey Demain is the founder of the Allergy, Asthma, and Immunology Center of Alaska. He's a clinical professor at the University of Washington, Department of Pediatrics, and an affiliate professor at the University of Alaska, Wami School of Medical Education. He is a past president of the Allergy and Asthma Foundation of America in Alaska, and has lived in Alaska for almost 25 years, where he has witnessed and researched the environmental impacts of climate change. Dr. Demain has numerous peer-reviewed publications and has authored 3 textbook chapters. So we'll hand it over to you.
It's a pleasure being here. Thank you very much. I wanted to just open this by referencing the Lancet report. It was published in 2018. It was actually just a beautiful paper, if anyone would like to review it. But in that paper, it was to compile scientific data. It reported that climate change was the greatest health threat of the 21st century. And of course, we have heard this through numerous organizations, not the least of which was the IPCC. So we just published a paper in 2019 in February. And when we reviewed the literature and reviewed the science that's been done, one of the things we found is that there's not a lot of robust data on the direct impacts of respiratory disease. So we definitely see rises in respiratory disease. We're certainly correlating that with rises in pollution, CO2, as well as temperatures, just like Eileen just explained. However, it's very difficult because there's so many multiple variables involved. So what I'm going to do through a few studies that I'm going to talk about is try to make a connection between what we're seeing in the environment and what we're seeing in the clinical world. So when we look at the factors that are associated with allergic and pulmonary disease, they're vast. Any one of these particular impacts we could spend hours on. Certainly we've talked about or heard about the microbiome and biodiversity loss. The hygiene hypothesis has been around for about a decade, but we have changes in home construction, dietary habits, changes in our activity level, childhood infections, so it goes on. So our focus today is really going to be talking about industrialization, changes in antigen exposure, and how it links to climate change. So this is a nice study. It looked at how many papers were actually published and how often was allergy recognized in the pre-industrial era. Well, the honest truth, by the pre-industrial revolution, there was only 2 papers that recognized and reported allergic disease. But now we see that 30% of our population is at risk. And when I did a PubMed search a few months ago, there are over 30,000 manuscripts that are addressing this. So we've certainly seen a dramatic rise in allergic disease in the last century and a half. Now we look at changes in asthma prevalence. Pardon me. Certainly that's gone up. This is the WISAAC study, one of the largest studies ever undertaken, looking at the actual prevalence of asthma. And you can see that virtually every line is going in an upward trend. Australia being the highest, but New Zealand right behind, Scotland, Canada, and there's the US, the UK, and Israel. As you can see, these are all westernized countries. So we look at worldwide asthma, and where it's not highlighted, those, we just don't have any reports from that. So we take this map and we lay it across with the map of pollution. And you can see there's certainly some correlation with high evidence of pollution and evidence of asthma. Some countries may underreport, like I said, some don't report, but there's definitely some correlation there. When you look at areas of pollution, the most dense areas are going to be China, India, and then certain areas of the United States. So in summary, we have 1 out of 5 Americans have either allergy or asthma. So the prevalence of allergy and asthma in our country is higher than the total of the next 6 in line. So this is a very significant health impact in our country. It's a very significant monetary impact in our country as well. So when we look at climate change, there's a lot of variables, and I'm going to certainly touch on some, but 2 of the most important are rises in our carbon dioxide level as a marker of climate change, and that is right now estimated at about 415 parts per million. We see that strongly correlated with the rises in temperature for global areas. Of course, in the northern latitudes, we're seeing rises in temperature 2 to 4 times that. So again, when we look at the health impacts of climate change, it's vast. Today, we're going to really just be talking about air pollution and air allergens, and I hope we have an opportunity to discuss some of these other areas in future webinars. Insect and related diseases is one of the areas that I've done most studying. So when we look at climate change, what we see associated with allergies is that we have plant growth that's faster and higher. We have plant biomass that's increased. We have increased pollen production, increased allergenic proteins. So one pollen is more allergic now than it was in 100 years ago. And then we're seeing earlier and longer seasons, especially in higher latitudes. So I'm going to highlight a very, very good study. This is done by Louis Ziska at Duke University. And what he did, so this picture is essentially small greenhouses. Well, all the variables are controlled. Everything is the same in each one, and they're growing ragweed. So they look at pre-industrial CO2 levels, which were 280. Current levels at this time were 370. Now they're 415. And projected CO2 levels of 600. What we found is the ragweed biomass, the ragweed pollen, increased 132% with that increase from 280 to 370 current level. And then if we take it one step further to 600, that increases another 90%. So we're seeing that CO2 has a direct impact on the biomass and pollen production of plants. Now, Dr. Ziska took it from a laboratory environment to a real world environment. He looked at urban Baltimore, suburban Baltimore, and rural Baltimore. And he had very controlled patches of ragweed. So they were just living in the air, it's in the environment. Now, the CO2 in an urban area is approximately 30% higher than in a rural area, and temperatures are almost 2 degrees Celsius higher in an urban area, and that's what we call the heat island effect, and I'll talk about that later. But what did we see? Well, this is a very nice graph that depicts it. The yellow bars represent rural, the red represents urban, and the blue areas are really more of the suburban areas. So what he found, is that the ragweed biomass in nature increases 189% in the urban area compared to the rural area. And in the suburban area where you have high density of population, it increases 66%. So this was a very important finding. So it's not just in a lab and controlling only CO2, it's in a real world environment that has these impacts. So this was a very nice study by Dr. Choi, and looked at 4 chambers. And in those 4 chambers, they were all controlled for variables. The only variable that was different was rising CO2. So what they found is we're measuring what's called AMBA1. So if you take a pollen grain of ragweed, the major allergen is a peptide called AMBA1. So that's what they're measuring. And what they did is looked at the current level of CO2, then going up to 550 to 520, going up to 600, 620, and then going up to over 1,000. So what they found is going from current level to 500, that was a 67 increase in the allergenicity of one pollen grain. And then taking it one step further, going up to 600, from our current level, that went up through 236%. Now raising it to the 1,000 level, from our base level of 380 to 400, that increased 285%. So you can see the graph on the right. So with higher CO2, you're going to have greater allergen potential of one single pollen grain. Now this, when you put this together, earlier seasons, higher biomass, increased AMBA1, this was a study done by Singer. So when you put all those features together, what you see is the allergenicity associated with climate and increased amounts of pollen being produced and the increased level of AMBA1, we have a very significant increase in the allergenicity potential of our plants. Excuse me. And now what we also found is that the length of season is playing a significant role. The length of seasons as far as pollination cycles, because frosts are ending earlier. So as we go further north in latitude, we find that the number of days for producing pollen is also increasing. So now we have longer pollen seasons, greater levels of pollen being produced, and greater levels of allergenicity. Now, this is depicting also the similar type pattern, and this was presented by the Environmental Protection Agency. So you can see the further north in latitude, the longer the pollen days over the period of 1995 to 2013. So it's not just happening with ragweed. Ragweed was just a model. Also, there were several studies looking at trees, particularly birch trees. And of course, you're not going to grow birch trees in a lab, but they look at urban versus rural birch trees. And these studies found that pre-season temperatures and sunlight are important predictors of tree pollen production. Now, we talked about allergenicity. In other words, one pollen is more allergenic, can cause more symptoms than if it has higher levels of the allergen. Well, in birch trees, that allergen is called BET-V1. So again, this is rural versus an urban environment, and there's a 30% increase in the amount of allergen, what causes the symptoms, in each pollen grain between urban and rural environments. Now, how do we put this together in how it affects people? Well, this is a study done by Dr. Ariano in Italy, and a 27-year study looking at the pollens, monitoring pollens, and that's monitored by what's called a Hearst trap or a Burkhardt trap. This is what we use here in Alaska on top of our roof. And the pollens they monitored were birch, cypress, olive, grass, and weed. And the patients were allergy evaluated with epicutaneous testing or skin testing, and they monitored climate variables like solar radiation, temperature, humidity, and rainfall. So what did they find? During this time, there was an increased pollination cycle, meaning it started earlier in trees and weeds like we just talked about. There's increased pollen load, so each plant is making more pollen. Along with that, the increased pollen sensitivity was seen in our population. So to put that into kind of a visual, you can see the variables: solar radiation, days greater than 30 degrees Celsius, and temperature greater than 30 degrees Celsius. All of those increased. We also see on the right graph that season duration increased, tree pollen counts increased. Now let's look at the sensitivity. So during that 27-year period, Dr. Ariano found that he started with 15% of his patient population being allergic to olive pollen, for example. At the end of that 27-year period, 40% were allergic to olive pollen. This correlates with when you're looking at dust mite, which doesn't change because of temperature and CO2, the dust mite allergy didn't go up. It stayed exactly the same. So the finding or conclusion with this is that with increased temperatures, increased days greater than 30 degrees Celsius, and solar radiation, there may indeed be an association between higher pollen load, higher allergenicity, and the allergic sensitivity of our patients. So I'm going to take it one step further. So when you look at a pollen grain is very small, but the allergen is actually inside the pollen grain. These are very, very tiny particles. And they can, once these pollen grains open, those allergens are released, and that's what causes our symptoms. Well, these pollen grains can be triggered when it strikes the mucous membrane. It strikes the eye or strikes the mouth or nose. But other environmental factors can also cause that pollen grain to release all those allergens. So you have high relative humidity, heavy rainfall, and thunderstorms due to osmotic shock. Very, very nice data has been presented by Dr. D'Amato. But pollutants can also be a factor, and carbon particles will bind to those little allergens and make it significantly more immunogenic, meaning it's going to trigger an even greater inflammatory response. So there's been a correlation between high frequency of asthma crisis during heavy rainfall and thunderstorms. So we look at our next slide. This kind of depicts what happens in a thunderstorm. The pollen grains are pulled up into the clouds because of this, wind and osmotic event. Once they go into the water-filled cloud, those pollen grains erupt and the allergens come out. And now these allergen grains are what people are inhaling. Very, very tiny particles that go deep into the lung tissue and therefore trigger an asthma crisis. So when we're looking at a pollen, it's not just a pollen by itself. It's impacted by environmental factors such as solar radiation, weather changes, thunderstorms, rain, as well as air pollutants like particulate matter, ozone, nitrogen dioxide. Those are going to be associated with the release of those pollen allergens, and those will cause disruption of the lung lining. It also triggers an immune response, which will relate to significant inflammatory disease in the lung, allergic reactions in the lung, and actually lung damage. So I want to shift gears because I think this is important. I put this in because I wanted people to see this. Studies have been looking at what happens when you increase CO2 to food, to not pollen grains, but rice grains. Well, they found that higher CO2 increased grain length and width. Well, that may be good. But what it did is increase the chalkiness of the rice and decrease the protein as well as other nutrients. This is a very nice meta-analysis published by Myers in Nature. And this is looking at low pollen or low CO2 levels versus high CO2 levels. And it showed that indeed wheat has lower protein value, rice, lower protein value, maize, lower protein value. And these are grains that are important for nutrition throughout the world. Now with legumes, there was no change in the protein. However, like the other grains, there was a significant decrease in other nutrients such as zinc and iron. So this is a big concern. This may have a significant impact on our ability to provide nutrition throughout the world. Now, as Eileen already mentioned, we're seeing many more storms. I won't go into it, but this has been projected, honestly, for the past 2 decades, that we're going to see more storms and, more importantly, more severe storms. So obviously, these severe storms have a great impact from injury, from damage, flooding. But what we're looking at, of course, is what happens from a respiratory standpoint. So with water damage, there's a risk of mold contamination. And there's association, of course, with respiratory disease. So in our environment, especially our fixed environment, like our homes, if you add water, mold is going to grow. And this is going to be a very unhealthy situation, particularly for somebody with respiratory disease. So in a damp building, the molds that we typically see are Aspergillus, Penicillium, Stachybotrys, and Fusarium. There are others as well. These spores are very small and they become airborne and respirable and can be very, very unhealthy. So we also wonder, well, does mold spores change in the presence of higher CO2? Well, indeed it does. Lake did a study looking at increased levels of CO2 from 400 to 800 and found that mold growth or mycelia colony growth increased by 40% compared to the colonies at the lower CO2 level. So with higher CO2 and more moisture damp buildings from storms, we're going to see more mold growth. So what are some of the health impacts of mold? Well, the allergic reactions, absolutely. The most common are going to be eye and nasal symptoms. However, asthma is particularly problematic with mold. In fact, certain molds, particularly Alternaria, have been associated with more severe asthma. So this and the mold exposure can certainly exacerbate asthma attacks. You can develop hypersensitivity pneumonitis, allergic bronchopulmonary aspergillosis, and these are very severe, prolonged, initially acute, and then become chronic disease. Opportunistic infections, so molds that may trigger allergy in one person if someone is being under chemotherapy for leukemia or they have immune deficiency, those molds can actually become a pathogen for individuals. The mycotoxic effect, what people call a black mold effect, that's controversial and fairly anecdotal. It would take a very significant level of exposure for this to occur. So what about urban areas? We talked a little bit about cities, and I'm going to go through this a little bit in a little bit of detail, but air pollution and CO2 are certainly a big concern in urban areas. You have heat waves, increased pollen, exacerbations of chronic disease. You also have precipitation of storms and the heat-related impact. This is the heat island effect, urban heat island effect. So what we see is that temperatures compared to rural areas outside of an urban area, in the urban area, the temperatures are significantly higher, and also the CO2 can be as much as 30% higher in that urban environment. And we're seeing more and more populations moving into urban environments, so they're going to have greater impacts from these exposures in addition to pollution. I'm going to take you back to our pollution map that we showed earlier. So these are areas where respiratory pollution is going to be the greatest impact. And this is, I think, a beautiful view looking at it. So it's not only pollution like burning fossil fuels, but it's also pollution like the sands of the Sahara Desert. So there's a lot of particulates. You have wildfires that are great pollutants. So there's so many aspects of air quality that we need to deal with, and many of which are impacted by. So what are some of our common air pollutants? You have ground ozone, which I'm going to talk about a bit. Different type of nitrogen oxides or oxidated nitrogen, nitrogen dioxide being one of the most common, sulfur dioxide, carbon monoxide, lead, and particulate matter. By the way, that's Beijing during the Olympics, and this is Atlanta in our 1996 Olympics. I want to talk a little bit about ozone. You have good ozone and bad ozone. So what's the difference? Stratospheric ozone is what we call our ozone layer. It's a protective layer that's 6 to 30 miles above us. It blocks much of the UVB rays, and it actually helps in keeping our planet cooler. Now, the tropospheric ozone, also called ground ozone or good ozone, or bad ozone, sorry, it's not good, it's bad. That's near the ground level. This is associated with cars, factories, power plants. This is when volatile organic compounds mix with nitrogen oxides, heat, and sunlight, and that creates ozone. And ozone is going to be, if you look at the top right, ozone is going to be highest in the afternoon and evening when the sun is high and you have more heat and, of course, more traffic and pollutants. And that's going to create high levels of ozone. Ozone is associated with an increased risk of respiratory disease. And it also is associated with binding with some of the pollens that I mentioned earlier, and that can significantly impact more severe respiratory and allergic process. This is a really interesting study. It's an older study published in Lancet by McConnell, but they looked at over 3,500 non-asthmatic children, 19 to 16, in 12 communities in California. They followed these kids over a 5-year period of time. And interestingly, 7.4% developed asthma during that period. So they compared it to the number of sports they participate in. So these are kids that are outside running, mouth open, breathing hard. So you look at 0 sports, 1 sport, 2 sports, or 3 or more sports. And you find that the children participating in more sports have a greater risk of developing asthma. In fact, the 1.8 represents an 80% higher risk that they would develop asthma. So very interesting, but let's split it out a little further. They looked at low ozone communities versus high ozone. There was 6 of each. And what we found, or what they found, is that it wasn't so much the activity outdoors. You can look at 3 or more activities in low ozone, only 0.8, so was not increased at all. But if these kids are participating in high ozone environments, these urban environments, their risk is over 300% higher of developing asthma. So wildfires, Eileen, reviewed this very nicely. It's certainly associated with increased particulate matter, what we call PM 2.5, because that's small enough to go into the lungs and deeply into the lungs. To put that in perspective, it's about 1/3 of the size of a red blood cell. So it has a greater impact on human health, and combined with pollen allergens to make them more powerful, more immunogenic. The increased PM 2.5 is associated with cardiovascular disease, respiratory disease, increased hospitalizations. It's also been associated with the interference of lung growth in children and much higher rates of fatality. So again, the ground ozone can increase in allergen levels and potency. It damages lung tissue and can be associated with increased respiratory diseases like asthma, COPD, allergic rhinitis, and bronchitis. And repeated exposure may permanently scar the lung tissue. So some of the greatest impacts in our human health that we've talked about is climate change. The World Health Organization highlighted pollution as the greatest environmental risk to human health in the immediate time. They also have a caveat that this is based on current risk. Long-term environmental threats such as climate change may exceed this in the future. So when you look at kind of a summary of everything I just said, we looked at air quality and how it can be affected. There are increases in regional ambient concentrations of ozone and particulate matter and dust can be associated with increased respiratory diseases. Also, increased production and more allergenic pollens are going to be associated not only with the severity of allergies and asthma, but as studies suggest, an increase in the population that has asthma. And then aeroallergens act in other harmful air pollution with it to worsen the disease. So now we have more severe disease, lasting lung disease. And we have direct injury from the ozone, and the PM or PM 2.5 particles have also been associated with respiratory and cardiovascular disease, including increased rate of cardiovascular and respiratory death. So when we look at climate change, whether it's CO2, warming temperatures, and other factors that I mentioned, this is in our backyards. This is not something that's futuristic. It's happening today, and it's going to increase, not decrease, unless something is done. So we have those increased pollens, we have increased molds, we have heat waves. Things that I didn't talk about, it affects other plants. Poison ivy is becoming more toxic. Of course, the fire and smoke and air pollution. I didn't talk about insects during this, but maybe we can do that in the future. And then the food issue, not just the fact that food nutrition is going down, but we have to be concerned about other impacts on our food. And this is going to require future study, because this is going to have a great impact on the potential ability for us to provide nutrition throughout the world. So with that, I'm going to turn it back over to Sarah. But I'd like to just end with one quote. You can observe a lot just by watching. And this philosopher was Lawrence Peter Berra, Yogi Berra. So back to you, Sarah.
Great. Thank you so much for that presentation. So now we're just going to open it up for some questions. So I have a few questions that have come into the chat box, but again, if you have any questions you'd like to ask either of our presenters, just go ahead and type them in, and we'll be going through them. So the first question that I have is, how well are residential building codes responding to health considerations for the indoor environment? So if either of our few speakers want to start to address this question, remember to take yourselves off of mute if you're still muted.
Hi, this is Eileen, and unfortunately, it's been my experience that they really don't deal much with building codes and health. It's really about safety, and that certainly is part of health, but they're not looking at pollution and control and things like that inside, or chemicals and all those kind of products inside the home. Once you're in the home, it is your home. What you bring into it is yours. So very few organizations will dictate and do dictate what you can and cannot put into your home.
Yeah, I agree with that. I agree with Eileen. Certainly, I think our builders are becoming more aware, and there's more focus on what we call lead architects, where they're developing more green homes, so to speak, better filtration, better air quality techniques. Tighter homes actually will decrease the amount of ozone coming into homes, whereas homes where windows and doors are open and not adequately filtered, you're going to see higher levels of ozone in the homes as well. One of the things that is very difficult to control, and that is, just like it was mentioned earlier, the chemicals that we produce and bring into our home. So a lot of the indoor air pollution, much of it is what we do, what we cook, what we use, the chemicals we use in our home, the glues, the carpets, etc. So I think awareness and education will help that. But I agree, there's not a quality control that forces builders to do a better job.
Great, thank you. The next question was for Eileen. So for the Dilys air filter study, could you share what the room volumes were for that?
Oh goodness, this is about 10 by 12, so about 120 square feet.
Great.
And that, excuse me, that was for my office. It's for that particular study out, oh goodness, because it's a long room. That's my dining room and living room combined. So you're probably talking 15 by 20.
Great. The next question is, what would you recommend regarding HVACs on air-only mode during a wildfire? Then this person continues, if the home and duct air leakage rate is low, then this mode can pull in outdoor air pollution.
Well, once again, this is Eileen, and you want to check with the manufacturer of your air handler. So I have a heat pump, and I made sure when they installed it that I could handle a MERV 11, which is just below hospital grade. If you have an existing system, you want to check with the manufacturer of your air handler or furnace to make sure it can handle an increased and a better filter than, for example, most companies, when they come to check and service your furnace, will not put in the more expensive HEPA or MERV filters. They will put in a fiberglass filter, which small birds can fly through, which does absolutely nothing for your lungs. So and I kept mine going the entire time. I just had it on fan, and I was really diligent about, and you can't help when people come in or leave, but I've got a pretty tight house. My air changes right now are about 4.6 air changes per hour, which is pretty tight. It's impressive for a 1906 house.
Great. The next question is, are portable indoor air filters useful to improve air within apartments?
Well, this is Eileen again.
The answer.
Go ahead.
I was going to say there have been certainly the use of a HEPA filter, a freestanding HEPA filter, they certainly can be very helpful. Most people don't have the ability to have an inline HEPA, so the room HEPAs are good. But you have to consider the size of the room that you're using the filter in, and that freestanding HEPA filter will work. Again, its goal is to pull particles out that are less than 0.03 microns. So it will pull most of the particulate levels out. In fact, it pulls almost everything out of the air with the exception of viral particles. So they are quite efficient and quite effective. And there's a variety of them that can range in cost of between $100 and $200 up to $800 to $1,000. But again, it's going to be based on the size of the room, and the filter itself needs to be either washed if it's a washable filter or replaced on a regular basis. So that should be checked as well. But the answer is HEPA filters have been shown to be effective, especially when you're talking about indoor allergens. Now, as far as indoor smoke from a wildfire, there certainly may be a limitation there, and Eileen might be able to address that.
Yeah, so the portable air cleaners are certainly well worth it. Unfortunately, there are a lot of people who cannot afford, $350 to $1,500 air cleaners. That's why I introduced the do-it-yourself filter fan using the furnace filter. So it will definitely help clean the air, and anything you can do to help clean the air is worth it. So once again, yeah, you want to, and with a HEPA filter, HEPA air cleaners, the HEPA air filter itself can be quite expensive, and some of them actually have a charcoal pre-filter that you can replace. And yeah, so if you've got it, it's a great thing to do to help clean your indoor air.
I'd like to add one other point regarding indoor filters. Many companies make an ozone generating filter. So they not only do they not help, they actually have been shown to increase respiratory disease. They're generating ozone. That is not good to breathe. So there is no value in them, and there's definitely health risks in them. Consumer Report did a couple of studies and basically said they were no better than a coffee table as far as air filtration, and that they certainly can be very damaging to your lungs. So I would absolutely recommend do not use ozone generating filters. Eileen, do you agree, or your thoughts on that?
Oh yes, ozone, anything that says that it smells like a spring rain is generating ozone, and ozone damages lung tissue. Not a good thing to have in your home at any point. And some of the inline HVAC systems have an electronic air cleaner. On startup, they can generate a little bit of ozone. I've actually have colleagues who've had to remove them from their homes because it exacerbated their asthma. So you just want to be very, very careful and avoid anything that generates ozone just all the way, all the time.
Great. I guess and a general question that I had as well was where would you guys suggest going for more information about that people can find about steps they can take to protect their own indoor air quality or follow up on some of these topics? If either of you have a series of suggested resources or places that are really useful to go and could suggest some of them, I can also compile links to give to people in the follow-up email as well.
I can certainly would recommend the Asthma and Allergy Foundation of America. They do a lot of work looking at particularly indoor air quality, as you know. So their website is www.aafa.org. And so you pull that up and you can certainly access them. And they also have a site where you can ask questions and they can be answered, but they have a lot of material that's available to help you with your indoor air quality.
This is Eileen. I also think the EPA has some wonderful resources And then Tribal Healthy Homes Network, www.thhnw.org has some. And I know I get a lot of questions about vacuums, and I would be very careful about bagless vacuums. So I know everybody loves their bagless vacuum because they can see all the stuff flying around in the container, right? Well, the problem is when you go to dump it, you're only 2 feet from all those toxins that you just took out of your house. So I would prefer, and I recommend, HEPA vacuums with a HEPA bag. So they tend to be a little bit more expensive, but they actually work much better at protecting you and your lungs from indoor particulate matter. Yeah, so and if you do have a bagless vacuum, which people love, I get it. When you go take the canister outside, put a plastic bag on the top, secure it with a rubber band, turn it upside down and clamp it down. Now you have a bag. You have not exposed yourself to all those toxins in the home because they're still finding DDT and house dust. So, and tie it up and put it in your garbage.
If I could mention a couple of other websites that can provide significant levels of information that can help guide individuals regarding impacts on climate, impacts of environmental allergens. I would recommend the American Academy of Allergy, Asthma, Immunology and the American College of Allergy, Asthma, Immunology. Their websites are Quad AI. It's what that is AAAAA, so 4 A's and an I.org. And the American College is ACAAI.org. But if you go on their website, there's an area there for, let's say, patients, and there's a lot of literature that can be accessed. And so I think that could also be a helpful resource.
Great, thank you. So if there are any further questions, people can take maybe 1 more minute to type them into the question box. Otherwise, I was going to ask each of our presenters if you had any final thoughts you wanted to share with our audience.
Well, I would like to share a bit, and I think that we have certainly, there's an awareness across the globe that this is a problem, and it's important, even though one individual can't fix everything, we should all be cognizant of what's happening and do our best to make a difference as an individual. So it takes us into a better direction. You know, we're at a time where, you know, some of the benefits that we've seen with regulation have been reversed, and I'm afraid that we may be heading in some places in the wrong direction. We may be seeing the more ozone and more pollutants being produced. So I think everyone should be aware of how they can help climate, what they can do. So think about that as an individual, and also, you know, the strongest thing we have is our vote. So make sure that your representatives, you know, feel that this is an important issue, and use that as one of your guides for your voting.
Good advice. Thank you.
So we did get 1 more question in, which is, are appliances with brushless motors likely to generate less ozone than older appliances with motor brushes?
This is Eileen. I honestly don't know that. What kind of appliances are they speaking about? Maybe that would help.
Cleaning appliances, I think.
Oh, they're talking vacuums with a power head. No. Power heads are great. If you have carpeting, they really help get the deep dust out, but you've got to vacuum a lot longer than you think you need to. I don't think they generate any ozone. I think they help to pick up particles. I have never seen any studies to that effect. Yeah.
I would concur. You know, again, I've not seen studies either, but I think what Eileen says makes perfect sense. I don't think they're going to generate anything that would be harmful. I think their efficiency would certainly outweigh anything that is generated, in my opinion.
Yeah, I just don't think there's any way for them to generate ozone. They can, if they're not very good, they can generate a lot more dust, but that's not the question.
Great. So again, the webinar recording will be available after the fact. So unless there's any further thoughts or questions, I'll just go ahead and close this out.
Thank you so much.
Yeah.
Thank you very much.
Yeah. Thank you. Thank you so much to both of our speakers for sharing a lot of really great and super dense information today. I think we all learned a lot. Again, the webinar was put on by the National Safe and Healthy Housing Coalition. We are a 600-member national coalition, and we provide both informational webinars and other informational exchange like this, as well as coordinating advocacy to federal policymakers on healthy homes topics. So if you would like more information about the coalition, or if you'd like to sign up if you're not already a member, you can visit our website or send me an email, and both of those links are on the screen. So again, there'll be a recording of this webinar available afterwards, and I'll also put into the follow-up email some of the links that we talked about that have further information for people to check out. So thanks everyone for your attention and presentations today, and have a great rest of your afternoon.